Welcome back. You're listening to the panel discussion, Capitalizing on the Next Wave of Technologies for Connected Government, sponsored by ServiceNow on federalnewsradio.com and 1500 AM. I'm your host, Jason Miller. My guests today are Frank Konecki, the Chief Technology Officer at the Air Force, Phil Klokas, the Associate Chief Information Officer of the Public Building Service at the General Services Administration, Dr. Michael Valavula, the Chief Technology Officer for the National Agriculture Statistics Service at the Department of Agriculture, and Bob Osborne, the Chief Technology Officer for Federal at ServiceNow. First segment, we kind of went through what everyone's kind of doing around IoT, where it fits in with your infrastructure, how you're modernizing. Let's look at the other piece of this that I think is important is part of the workflow, because all this data, all these sensors, all this cloud, it changes the way each agency works. So let me start with Frank. When you guys, as you guys move toward this connected devices, this new infrastructure, this collecting of data, what's that mean for the people who actually, if you will, are doing the work or using the data with the workflow?
Okay, well, let's take a good example, and that's engine maintenance. All of a sudden, as you start getting engine maintenance data, you realize that you have to have parts. So we're changing the logistics part flow right now. But all of a sudden, you come back and say, I want to be able now to have a part ready for me when I land based upon what I'm getting in my IoT sensor devices that says this part is going to wear out next. Okay, that changes the logistics system. It changes the way that the maintenance people actually work, because now they're expecting something to be there and to work on that engine when it lands. This is totally different than the standard. Standard is to come and land, look at what's going on, try to figure out what you need to do. So it's changing policy, it's changing procedures, it's also changing the systems, because now the systems have to automatically respond back and say, hey, I'm going to send a part here. Which has never been done before. And so as this progresses, you're seeing there all sorts of changes are happening to the logistics systems right now as they go farther and further on. In fact, we're getting to the point now where we're actually doing 3D printing of parts. And some of these parts are going to be printed on base now where the event is going to occur. So this is automating more down the path and looking at what is it doing to the people. Mechanics are having an easier job.
Hopefully.
Maintainers, yeah, they should be having an easier job. And so, you expect to have, you now have to pull an engine, immediately because you think it may be bad. Now you can determine what is really happening. So you can see that that's one example. There's lots of other examples where, we're looking at, IoT for fuel trucks and things, and what is the fuels on that truck? How full is it? Do I have to go back and get some more fuel because it's going to fuel the plane or not? There's all sorts of procedure changes now are occurring, especially when you look at the AI systems and resiliency and reliability of systems now.
I think it's a fascinating example because it's being more proactive versus reactive. Hey, this part usually lasts 5,000 miles. It's at 4,820. Okay, let's change it. Bob, jump in.
Well, Frank illuminates a great point, and that's the aggregation of data. And we've heard it in several of the opening comments. It's all about the data. But the challenge with that is not just finding data, aggregating it, and then starting to comb through what it really means. It's being able to share that information in a meaningful way. So I often refer to the term of setting the table to be prepared to take advantage of the new and emerging technologies. And that means putting together a framework within your architecture that allows you to move rapidly into adoption of new technologies. So in ServiceNow, we refer to that as modernizing and then transforming so that you're ready to innovate. So moving from not, kind of managing stovepipe systems that are supporting individual processes within lines of business into platforms that support business operations that have mission outcomes is really what the agencies are shooting for. So in order to do that, you have to aggregate information and be able to put applications on top of that that can mine that information and present it for humans to make decisions or machines to make decisions in order to get proactive rather than reactive. When we talk about AI and machine learning in the workplace now, particularly in the federal workplace, the ability to have this data available for applications to run advanced machine learning and AI applications that give you the predictive and preemptive capabilities that Frank referred to avoid outages altogether, not just in IT, knowing when to replace a server or to add storage memory, but in operational outcomes like when do you replace parts on a jet engine, or when are tires going to wear out in a Humvee in the desert versus a jungle environment. So it's critical that you set the table, transform that basis of IT support that is going to power all of these transformative technologies that are introduced into the workplace of the future.
Phil, let me get you to jump in as well, because I think very similar to what Frank was talking about with the truck parts, you probably have HVAC, heating, air conditioning. Talk a little bit.
Yeah, Jason, it's exactly right. I mean, we have a program that we've implemented about 3 years now. It's called our GSA Link program. It's installed in about 85 buildings that comprise about 50 million square feet of commercial real estate. There's over 170,000 individual components that we're actually monitoring as part of the GSA Link program, with about 30,000 pieces of equipment. So as Frank said, with, again, the aircraft and the parts, our components within our buildings also are important to us because they fail too. You need to do maintenance on those things as well, and they don't get replaced all that often. When you buy a industrial HVAC system for a 20 million square foot building, it's it's not
buying it next year.
Yeah, it's not one of those things that you just replace out. But so it's a rather robust program, but there's really three legs of that stool, right? The old proverbial technology part, the process part, and the people part. You started the segment by talking a little bit about the process, and I'll be honest with you, the technology in many cases is the easy part. Right? It either works or it doesn't work for the most part, right? You may have to do a little tweaking here and there, but the two other legs of the stool that are equally as important are the people and the process. And they all have to be in balance for the overall technical solution or product or service to work. And if they're not in balance, that's when you get into problems. So process automation, really a big thing. We're doing a little bit about robotics now, starting to robotics process automation. And the really interesting thing that I have noticed personally with robotics, it's giving you and forcing you to look at your process. You should never automate a bad process, because that's just going to compound the issues over time, right? Because you're just doing bad things faster, and that's not a good thing. So really have to take a hard look, and I think technology is driving us to take a look at our business processes, and maybe we don't even have to do it. That's the best of all. Maybe eliminating the process, don't automate it, don't do it, just move on to the next one. So robotics process and automation is something else we're starting to pull the thread a little on.
I've been so surprised how quickly the government has really picked up on some of these things like RPA
Right.
and even AI. Bob, jump back in.
Well, Phil makes a great point, and he's mentioned it twice now, and that's the people aspect of new technology introduction into the workplace. But asset management is really what we're looking at, is advanced asset management, whether it's a physical thing, a virtual item, or a human. If you think of that as an asset that needs to be in the right place at the right time to perform a function in a workflow that has an outcome, that has a mission outcome, in the case of the government, it's really critical to understand the human element, because in all the work use cases that we're discussing right now, the human's capability, what are their skills, their training, their abilities, what tools do they need, have to be at the right place at the right time when the airplane lands or the HVAC system is going to be repaired. And those become highly valued assets in many cases when very unique skill sets are utilized. That if we leave that part of the equation out, that leg of the stool, as Phil said, it's really going to result in a failure and a delay in getting that system or that capability back up.
Yeah. Michael, jump in, because you guys have a huge people problem of getting people to do those surveys. But
that is correct, because I want to just mention about this is not more of an evolution, it is more of a metamorphosis. And if you look at the transformation, because we are looking at statisticians and mathematicians that we have hundreds of them in our organization. That's all they do, they crunch numbers. And they want to understand what is the reliability of these sensors and how accurate are they, who is calibrating them, can we trust these numbers? Because first of all, that is the fundamental question. What is the integrity of the system? What is the security? Where do we put security? At the endpoint, or at the node, or at the data center back? And also, who is managing this cloud? So all these things, who touches this information? Because we want information that has not been touched. So we like the integrity aspect of it and the reliability aspect of it. So unless they are convinced that this is clean, the data is clean, in terms of it was like an embedded system that sent the data out, and then we have to find out a way to reformat and integrate those data elements and match them with different manufacturers. John Deere for one big, Case is another one, and DuPont, Pioneer, Monsanto, Bayer. There are so many players, and it is very hard to come up with a single standard way of collecting and formatting data and sending it to NAS. That is the challenge that we have amongst ourselves. To how do we do collection of the data, and then how do we analyze the data, and of course how do we develop models, and then how do we train our people, basically. So now they are statisticians. Now we are asking them to move into AI and machine learning and come up with a way to model, and they also do the day-to-day work. So that is a very, very big challenge for us.
Phil, jump in.
I couldn't agree more. I mean, the normalization of the data with so many different makes and models and proprietary information, whether it's on the farm or the farm equipment or within the building, we have hundreds, if not thousands, of different makes and models of products and services that are in our building collecting this information. Most of them dealing with non-standard protocols. How do you collect this information? How do you normalize this information? Because that's really what's key. We have to be able to be in a position to compare apples to apples, because that's what gets us into, I think, into a little bit of an issue when we have these different systems and they're all doing a little different thing.
Adding to the complexity here, we already use satellite data. And to draw a picture of the US, it takes like 2 to 3 billion pixels for us to do it. Imagine getting the data at a very high fidelity, about 200, 300,000 more accuracy, and then the numbers will go into trillions. We need to have a way of handling the data, of course, and then that is going to add more to our systems space. And also, are we going to keep all this information, or are we going to filter it out at the edge and bring information that we need? Where do we run our analytical models? Do we go to these different clouds that gather the information and run our models there and only bring the data, or bring the data? It won't be physically possible to bring the data in because we just don't have the big pipe to get the data, and we have to secure the information. We probably don't want to do that. Moving forward, we will have analytics and our models run in different clouds. We will bring the data and integrate the information, and then we will validate the information, calling the farmers or ranchers or agri-businesses to see this is the information we got, this is the model is telling us, is this correct? Instead of asking for information, we will give them the result of our analysis and validate the information, because that will reduce the burden on the farmers and ranchers, make our life a lot easier.
Well, if you need some T1 help, Mike, Phil has an extra one that he can provide. Bob, solve this problem for us. Come on.
Well, while it hasn't been solved yet, what we're talking about it, and we're hearing great examples from Phil and Mike, and of course Frank has the same challenges in the Air Force, is this ability to extend and contract the boundaries of what you consider to be the enterprise that you're managing in this type of a very complex architectural environment. And being able to do that, you have to be able to transcend the way we've traditionally looked at how you provide availability, access, and security to our employees and our citizen customers. So this type of a almost human aspect of transformation and constant reaction to different stimuli takes us beyond just the traditional, let's modernize our IT infrastructure so that we can transform how we deliver services and then innovate and bring in new technologies. We have to go beyond that, almost to a sentience, an ability to understand, sense, and then respond in an automated fashion to new inputs and requests for access for data from different points. Mike mentioned all the different partners that they deal with, the companies that are providing sensor data that affect the analytics and the projections that are done by USDA. Critical data that has to be pristine throughout the process. being able to trust that is going to require a technology approach to securing that type of an environment that isn't done today. We do it in silos, and we hack it up, and then we try to share it in other non-standard methods. That's fine, but try to run artificial intelligence and machine learning on that. It doesn't work because you've broken the capabilities to run through those data sets.
Frank, jump in for this, because a lot of the challenges that Phil and Michael talked about and Bob referred to, Air Force is facing, obviously today, the unstructured data, too much data, how to bring it all together, different clouds, and then Bob brought up security. So we could pick where you want to
Let's go to
start.
security.
Yeah.
If you look at the Air Force, we are a city, multiple cities. We have chemical plants, we have manufacturing plants, we have computer plants, we have HVAC, we have everything else across the board. The question is, how do you secure all this, and how do you believe the data? For the, and this comes back to us, we have lots of old systems with lots of old IoT. And the question is, how do you secure that? I mean, going forward, it's cool to say, okay, we're going to have a security mechanism for these new IoT devices. The old ones are the problem space that we have to satisfy at some point in time. And the question is, how are we going to look at it from a viewpoint of, let's look at the base and determine the security of the base, not pinpoint it and say, oh, that new device, the HVAC is really cool, but I understand that. But I have some sensor in a chemical plant that's faulty, and all of a sudden, something else happens out there. So we're looking at security from a viewpoint, and what AI techniques can we actually use to monitor prior histories of those devices in terms of determining, is this an abnormal behavior, or is this a behavior that's expected, especially for different times of the year? Because it's going to be a weather-related issue. Sometimes it's going to be a mission-related issue that's going on. Because if you're doing a mission, all of a sudden lots of things change.
Exactly. We're going to take a quick break, and Phil, I'm going to bring you into that conversation, because as you just mentioned, when you buy an HVAC system, an industrial one, you don't buy it every year. So an old sensors is probably a challenge you're familiar with. But let's take a quick break. You're listening to the panel discussion, Capitalizing on the Next Wave of Technologies for Connected Government, sponsored by ServiceNow on federalnewsradio.com and 1500 AM.